Hello, YouTube and LinkedIn and Twitch and everywhere else that this hardware live stream is going live. My name is Chris Gamble. I'm the head of hardware and developer relations of Goliath. Today, we're taking another look at the Lute board, which is what we did. That's L-U-T-E, not L-O-O-T. That's what we did in the last live stream. And this is part of the Aludel platform, really just kind of the set of boards and cases that we're putting together here. And we're going to continue on this today. What you'll see on screen here is actually I had ended up, after the last episode, session, whatever we call it, I ended up exporting the 3D model and of the board that we worked on, and then imported it. I actually added the Elixir board, which is what it is meant to plug into, and I imported it into FreeCAD, and that's what we're looking at here. I'm just going to do a quick sound check to make sure I'm on the right microphone. I did change stuff yesterday, so let's just double check. Looks good to me. Hopefully good to all you too. Okay. Yes. So today what we're going to be doing, if you saw the cover sheet for this, is that we're going to be adding a cutout because the 3D model actually isn't here. That's interesting. Okay. So these four drill holes right here is actually for a. Wow, I should really have one of these in front of me. It's for this right here. Let me go large. Okay, so this is the Aludel Elixir, and I'm not sure the detail is going to be there, but this is a terminal, 2-pin terminal block. This is meant as the high voltage input. So the Elixir is made to handle a wide range of input voltages. This came from our work doing CAN asset trackers, so using the CAN bus, which means that you probably have 12-volt battery voltages available, but you want to have some overhead there. And then also hoping to get into higher voltage things. 24-volt supplies are very, very common in industrial workspaces. 48 volts on PoE. So this can do, it's a 60-volt converter, but the Rev B board has the wrong sized diode on it. So really it's rated for 40 volts right now. Hopefully we'll get up to that 60 volts in future revs and do some testing around it too. But the converter is made for 60 volts. And so at 48 volts, I feel like that kind of margin would be sufficient. Or 48 volt bus, I feel like that would be a sufficient amount of margin on the controller. And also that's not the absolute max for the buck converter. It's actually higher, but anyways, I feel good about that. But the long and the short of it is this terminal block is tall. It's taller than just about anything else on board. And so it would actually be popping up out of the board. So out of this plane right here. Like that. Oh. Okay, so this is actually orthographic view. Is orthographic? Let's see, view. I'm on perspective view rather. So we can go orthographic, and now we see it nice and flat. So this is. I'm not sure. I'm sure mechanical engineers could tell me what the difference is. I don't actually know. But this is basically that dead-on view. Oh my gosh, you're not seeing it. I'm so sorry about that. Classic. Feedback is important in electronics. Okay, so this is the view. So this is what we had been looking at, perspective view. And so it's actually pretty hard to get it kind of flat there. I guess I kind of did it, but you see it kind of goes off to the distance to the vanishing point there. But then orthographic view is basically say, okay, let's look at the 2D view basically, and the dead on shows it all right there. Okay, so basically this connector here, this terminal block, comes out of the board. There's nothing to really do about that. I actually think it's a good thing because it's higher voltage. I'd like to be extended. I've also, between revs A and B of the board, I actually ended up swapping the voltage location. So the higher voltage is actually closer to the case now. And that's because if there is, so again, let me go back to this view. Hopefully don't forget. If there is a clickboard in line here, again, I should be better prepared to plug stuff together here. Got boxes and boxes of hardware, and none of it is currently within reach. Look at this Adidas box of hardware. Okay, so if we take the longest version, so this is the biggest version of a clickboard. This goes all the way to the edge, and so if I plug this in on this side. You can kind of see, so basically this connector is right up against this. So the closer input here is ground and the higher voltage one's over here. And that's just because of, clearances, wanting to make sure it's further away from the board. But generally, I feel there's also a bunch of depth here, right? So you want to be able to have like if you have a stripped wire, you want to be able to insert it deeply into this terminal block. All I'm doing here is just convincing myself over and over again that this is the right connector. Really, it's just about all that fits in there, and I think it's a-okay. If not, please let me know in the comments or our forum. Okay, so I'll keep that on the table here. All right, so I think we're all on the same page here. So I think so. Let's go and look at this board. Look at this board set of boards now in KiCad because this is actually just an export from KiCad. I do not currently use the Step Up plugin, which I should. I also had quite a bit of trouble getting this aligned because of just how FreeCAD is. So you can even see it's kind of off base a little bit here. This would have been pulled a little bit that way. Ultimately, it doesn't matter. I just wanted to kind of see it in situ here. Yeah. And I generally from the last video, I am actually feeling pretty good about the alignment. I actually did have to move some of the pads a little bit to, when I was plugging the boards together in 3D, it actually became very apparent that I was just a little bit off on some of the pads. I think it actually would have been okay, in terms of like slop and like things would have plugged together, but it might have been a tight fit. And now this much more closely matches because I moved the stuff around, not in the 3D modeling program here, but in KiCad, which also has a 3D model export. That was actually really, really useful. So if you're a user, and I think this is one of the best functions. My program did crash last time I did this, so is that the right? Yes, I'm kind of like looking at this being like, that looks a lot like the Aludel. And the answer is yes, actually, it does look a lot like the Aludel because that is the Aludel's topside copper, bottom-side copper, topside copper that we actually put in this design. Also, one thing I mentioned last time was my concern about the orientation. One more time on me. So the orientation of the things on the Astentis board, so these logos here, and then where the headers would be. But so this is kind of what the Aludel platform looks like all plugged together, right? So the Astentis on the top, the Aludel's inside, or the Elixir's inside here rather. I went and assembled a bunch of them actually the other day, and we do want it to be like this. So in terms of where the connectors are on the board, that also feels correct to me. In the same orientation, it would be much like this one is actually, where the USB connector is actually at the top, which may be a little counterintuitive because, like, why would you want to have the stuff at the top? But the idea being that most of the time, if you're doing some kind of field wiring, which we'd be doing less here because the field wiring is effectively on the front panel now. But if you're doing front field wiring and you're using the full Elixir setup, you would have wiring coming in here. And that's what we do on just about all of our reference designs. We have the wires coming in through the bottom, sometimes with cable glands for strain relief and also waterproofing, although this is not a waterproof design. And so this feels a little bit weird to have, kind of cutouts and programming headers on the top, right? Like USB cables like this. Usually we do right angle USB-C to program it. But then because we also have this antenna, we have the UFL for the cellular to antenna here, or we could do dual if we're doing GPS on the 9160. Usually we do it on the U-Blocks Neo U9M or whatever that is. So then that comes out the bottom. Comment with an opinion there. Because of that, basically, I want the kind of the digital side on the top. Whether or not that's the best idea, it should be possible to do both ways, though. So it would just be, if you had the logos on here, it would be upside down. I don't know if that's a huge deal. Perhaps we can make two versions in the future. Okay. So let's go turn some of this stuff off. So what we really need to do here is, unfortunately, this does not capture. So those are the 4 holes that I mentioned before. So this is from the terminal. You're not seeing this. You're not seeing this. I need some kind of AI to make this work. Okay, so what we need to do is we need to go and get the outline of the terminal block. That was the word I was looking for. We have the 4 pins here. We talked about the 4 pins. And now we want to see the outside here so that we can then put a similar cutout in the PCB. So we're going to do that with edge cuts. I'm just going to do this as an just a very basic thing here, right? So like as just a guess, I can just say, oh, well, it's probably going to look kind of like this. But I don't want to actually guess. I want to take data, right? So that I can already see is not square as well. Now my computer can handle it. Let's see. So now you see there is a cutout here, and this cutout, then I would expect the 3D model to pop, the terminal blocks to come through this here. So then the benefit of this, maybe I should get to the benefit, is that if you were using the Lute board to have wiring land on this thing, right? That is one of the ideas of this board, is to make it so that we can put terminal blocks directly onto this board. So the idea for the first version of the Lute is going to be just relays talking to digital I/O from the Elixir, and then terminal blocks. So then we're trying to make a flexible kind of basis for doing this sort of thing, so we can put other stuff on in the future. But if it's just a couple of relays and a bunch of terminal blocks, well, you're going to have terminal blocks here. You also want to power the board from the front, though, because this is really meant to be kind of captive. I should really just open this thing up. It's going to be captive on here. So how else would you power it? There's no cutouts otherwise. So unless you just be relying on the battery otherwise. So if we assume that the Lute is sitting on top of this case, there's terminal blocks on the top of this case as well. Well, the Lute is going to allow us to run a second set of wires down into the box itself. Okay. Let's see. Yagya asks, will you test the RF performance of the case for internal onboard antenna applications? So no current plans to do that. We could. It's probably a good idea. But one thing about the Elixir, do we have the Elixir here? We do. Oh, well, it's not really showing all the models that I wanted to. But this is a 3D export from the Elixir's KiCad files. And this actually, so this is the cellular GPS modem here, this silver rectangle. That's the NRF9160. And there's 2 UFL connectors here that are just like a coaxial output. And then sometimes I put those out to SMA on the outside of the case. There's really no internal antenna for that one. Now the the ESP32C3, there is an internal antenna, but it's pretty low stakes for that sort of thing. Plastic case, followed all the design guidelines. Could test it, probably should test it, but no like kind of blocking actions from that right now. So we'll see into the future hopefully. All right, so this is roughly what we're hoping to do today. Here is do a cutout. How can I do Z? There we go. So cutout in the PCB. Want to make sure that this sidewall is not too small. I think there's probably restrictions from the PCB vendors as well, not to mention just some of the practicals. We could just slice this and make sure and just have it as like a slot, but it's not going to look quite as good, I think. So we'll have to see what it looks like. I think the first step might be to go and add. How would we do that? I guess I'd have to re-export. What I'd really love to do is get the 3D model of that terminal block into the 3D model that we exported for here. But I think the first thing we're going to have to do is open up the program. To open up the Elixir board, rather. So I need to do PCB new. I'm going to open a second version of KiCad effectively, but just the layout part. All right, so let's go. Let's 1 second here. Open recent. Stentus. Elixir. Here we go. All right, so here's the Elixir board. These files are open source. Looks like this still has everything turned off. I think I might have saved this by accident. So I guess I could go and do a git reset here. Let's do that. Do I have the Elixir open? I don't seem to have it open. So I have a terminal. I have a terminal open right now on another screen. Just try to get that up here. All right, so yeah, this should be okay to put on screen. Just double checking. Yeah, should be good. All right, let's do this over here. All right, so I use Guake to do terminals, and let's do CD Elixir. Elixir, I know how to spell. We see that this is a GitHub project here. And we're still on. Huh. Layout after session 5. Let's see. Well, in classic fashion, it seems I did not commit my changes. So I'm gonna have to go fix it. So let's go fix it and then commit changes because, oh boy, yeah. Well, let's just make sure though. I thought I had layout after. So I'm checked out of session 5. Git branch L. No. Okay. Yeah, that's all I got. So I've just got main and session 5. So, all right, let's just go fix this. So let's turn stuff back on here. I think I deleted planes though. Oh boy, yeah. All right, let's try a stash. Git stash. Let's see what this looks like. Close this. Going to open it back up. All right, this is back to how I want it to be, I think. Looks like some of the footprints are turned off. All right, there we go. Back to the madness that is here. Okay, so I think this looks right. I mean, this is what I sent to production too. So I think the session 5 is throwing me off a little bit. Okay, what was I doing? All right, so first I want to do is 3D model, or just look at the 3D version of this. All right, we can see that I did not properly put in the 3D model for this thing, so we can see how we do that. I could have swore I had one though. All right, let's go to the project folder. No, not there. 3D. It'd be great if I knew what this thing was called. 1825. I could just click through all of these. Huh. All right, well, let's see if we can go find it. Max. It's in the folder. I have to feel like I've definitely downloaded this. Let me just check my downloads folder. Nothing there. Let's check the Goliaths folder. I know this is not thrilling television right now. I apologize about that. This is made by, this is a Weidmuller. No, I do not appear to have this anywhere. Okay, let's go get it. Let's see if DigiKey has it. Here. So this is the part. 2-pin terminal block. There's a link. That's a good start. Come on, 3D model. There we go. Look at that. Ultra Librarian. Thanks, DigiKey. I love you, DigiKey. All right. Downloads. I'm just going to do this off camera or off screen, I suppose. Modified. Oh, what? It didn't download. It's got this beautiful 3D model here. Do I have to download it separately? Oh, there we go. Separate. That's weird. Thanks, DigiKey. Nah, you're great. All right, downloads. There it is. Okay. I know you're not seeing any of this. I apologize. You just never know what's in your downloads folder, right? I mean, all right, so we're going to do the Elixir hardware. All right, so now we're in the repo here. So usually what I do is I do an input folder and then either mech. Oh, no, sorry, that's the wrong one. 3D models. Here we go, 3D. Put that in there. Now I should be able to select this from the dialog. Nope, that's the wrong one. It's this one. See, this is where it's confusing. Because I have two open, I have PCB new open separate from the KiCad kind of like launcher and its secondary version there. It's not showing. All right, so let's do this. Let's go find that. If you didn't know in KiCad, there's kind of it dumps you into the default folder here, but then one of the options is your project folder, which is great. And then it's really easy to find this thing. All right, so now just gotta put this in the right spot. I am not certain if that is the right orientation though. Let's see. So in the, I have a bare board. Well, I guess we'll have to do it after the fact. Looking at this board, the little push button things are on the bottom. So I actually, thickness too large, that's fine. Let's go back to the 3D model, Alt 3. It'll put it in here, but it's going to be, yeah, so that is backwards from how it should be. So that's fine. We're going to flip around. Let's go back to the model here. And then we'll rotate in the Z axis. Why am I in inches? Good Lord. What is this, America? Come on now. All right, so we're going to do a rotation on Z. There we go. And then we're going to move it in the X direction and the Y direction. Then I usually look at the bottom here for this to just see how it goes through the through holes. Very scientific. This is called the guess and check method. That looks about right. All right, let's see how that looks. Should fix it. Ta-da! Great. All right, so now I'm going to close the 3D viewer. I'm going to export step file. This is the Elixir hardware output step. That's definitely the wrong date. 2409191328. Should be default. Let's ignore the DNPs. Looks good. See if it works. All right. The other thing we're going to do next is, so now we have a 3D model. That'd be great for verifying the actual like cutout. Once we swap in the other file in 3D, should be pretty easy actually, because okay, so it's a success. Took 10 seconds. Great. There's the file. So the nice thing is, so now we go to the, this is now the Lute page, right? And I have already connected these two things together. The way that I did this actually after the stream last time. But what I did is actually I used one of these connectors here as the anchor for the 3D model. So just like I just did here, I just exported the Elixir board 3D model, and now that's a component that gets pulled into the Lute design for verification, right? So now we're going to go and switch the Elixir board that's plugged in here, and we should see this 3D model here. But the way I did this is I forget, honestly, I forget which one it is. We'll find out in a second here. And I should just be able to go in there, change the timestamp to the one that we just did. The position should be the same, and then it should just like literally match up. So that's in theory. All right, so let's go to the Lute board. Let's turn off user 2, user 1. These, I think it was this one. Oh, good guess. Okay, so here is the, see that this is the model from before. I did this a week ago. I'm going to go copy this. I'm going to hit plus. I'm going to do this again. Change it to today's date. Not sure why. I don't think it wants to import it twice. That's fine. Let's just go and select it, I guess. It's not in there. I gotta copy it over. I pulled it. It makes sense that I did this, but I don't remember doing it. Or I actually copied it because I want it to be a portable thing. So I don't want to tie it to the repository that's on my local machine. I actually want to just bring that file over. So now the file, the export step file that I just did, that gets carried along with the Lute. Okay, so I did output step, here's today's date, and then let's go Lute. Okay, so this is the folder in Lute. I'm just going to copy this in here. So now you see I have 2. I should be able to go here and now select it, this one, and then that didn't work. Oh, it's crunching on it. That's what it is. It's like frozen. Do that because what it's doing is it is actually going and processing this couple megabyte step file and trying to figure out like how do I draw this thing, right? Especially when I've already drawn another one. So when I click and drag this around now, we're actually going to see another one off camera where it was originally placed. Look, there it is. Hello, friend. All right, so now I'm just going to do. Let's just copy 180 minus 180. There we go. It's just gonna come in for landing here. Oh boy, just copy that. Inches again. What happened here? I think it was from working with a local vendor. And this one, and this is definitely done in millimeters because look at that. Look at that decimal point precision. All right, so now we see they're just right on top of each other. So I'm going to go and turn the other one off. Oops, there we go. And this should line up. This is how I did it last time, where I just made the connectors line up. And if one of them is, if it's like square to that connector, it should be good for all the connectors. And that's what I was verifying as well. Okay, so now that's in here. We've got the connector. Great. And we should, let's see how close my guess was, right? This is what I guessed. I'm sure it's not very good. It would have worked. What's surprising to me is the height is lower than I would have guessed. I thought this was going to stick out more, to be honest. Yeah, that's interesting. I thought this was a different height. So now we could, I mean, in theory, we could do this just based on these dimensions that we're looking at here. Maybe I will do that. I was thinking I would also pull in the silkscreen. I guess we can do that. It's probably good practice. So we did that last time when we were just looking at just the top layer. How did we do that? We combined the, what did we export? We exported a SVG, I believe. Yes, because the DXF was like multiple layers. So I think we're going to just do a export SVG of now top copper and top silk and outline. So let's try and do export SVG, top copper, top silk screen, edge cuts. We should combine them all together. Print one page per layer. I think we want to do this. Board area only. See what happens. So Lute hardware board SVG. This is the wrong project. Well, I have a nice connection there now. All right, so this is, I have a mech folder. I have a mech folder. This is copied over from before. Elixirboard.svg. So that is what I did last time. Okay, so it was a elixirboard.svg. This is where I want to do an export. Right, export SVG. Front copper, front silk screen, edge cuts. I want to do board area only. Export. So Elixir hardware, Elixir board SVG. Okay. I'm going to replace the file that was there. So that's a new file now. Let's see how this goes. Let's try importing graphics. Okay, we do this. Let's do this on user 3 layer because that was, we did other ones. Oh, wow. Okay. Well, now I remember what we did before. We turned off the copper pores because otherwise you can't see a darn thing. And actually on user 2, I think we actually have the copper layer. So you know what, I'm gonna actually redo this one more time. So let's just do just the silk screen and let's leave the copper out. Board area only, color, edge cuts. Okay. So we just export it again. Leave this folder open. I'm just going to open another folder over here. I'm going to overwrite it. Okay. Import graphics. Should do the same thing. Use a layer 3. All right, there we go. Look at that. Now we can actually line this up. Almost line this up. Grid. 0.001 inches. Wow. It's still not enough. All right, well, that's about close enough. All right, so now we have the silk screen here as well, which should represent the 3D model outline. Wow, and some hieroglyphics. It does not like text, apparently. All right, so now, finally, we can start to modify this edge cut. So let's see how much space we have here. Are we back in millimeters yet? No, there we go. All right, so from here, so my grid should switch to millimeters. So that's about 0.5 millimeters. I'd say maybe we should, if we can do a millimeter and it, so let's see here. This is a millimeter. I think we're going to get a, let's do 0.75 millimeters. So we got to change our grid to be 0.05 from here to to here. All right, so this is now our 0. I've been hitting the space bar to make it 0 out. I'm looking at these values down here, dx, dy. Hopefully you can see all those. Let's now make this square. So that's 0. Cool. All right, that's good. Now let's do the same thing here. So from here, 0.75 is here. There we go. Grab this line. All right, how about on this side? Oops. There we go. All right, there's 0.75 there. So let's take this line out to the 0 point. There's a corner. And then finally, we should be able to do it here. Again, if it's not clear what I'm doing, look at the dx dy, right? I'm starting on top of the silk screen for the terminal block. I'm hitting the space bar, that zeroes everything out. Dx dy is now 0. Then I'm just going down vertically. So now that's 0.75 millimeters away. See, dy is 0.75 rather. Hitting the space bar again, that's my new kind of relative 0. And then I'm dragging this line to match up with that. So I could do, there we go. And then I'm also just kind of looking at it visually to make sure that this is square, right? So that it's straight up and down. Looks like it is. I can grab this. This will just match a corner. I can also validate if I go over top of it, it should be 0 dy, which it is. And then over here, should be able to make it 0 dy as well. See right there, that's 0.05 off. So that's how they get you. Let's make this square. This is where snapping can kind of get you in trouble. The corners want to snap together. So is this 0 dy still? It is. So that's 0.75 millimeters away from that line on the silk screen there. And then if I hit, so now I'm at minus 7.8 dx, 0 dy. If I hit spacebar again, now I'm 0, 0 in the corner. I can go to the top corner, make sure that's 0 dx. Go to this, hit the spacebar again. I should see 0, 0, 0. Great. Go over here. 9.2, 0 dy. Spacebar again. I expect this to be minus 10. Yeah, dy is 10, dx is 0. Okay, so now this should match even closer. If I go to the 3D model, the cutout should more closely match. And actually it is equidistant around the edge of this thing. So now we've made a cutout in the PCB that matches the 3D model and the silk screen of the board below it. Potential pitfalls, because there are some. If my silk screen is wrong, if my 3D model was placed poorly, if your board house has tolerances that are too high, you could start to just get this stuff. And that's really the reason to have 0.75 millimeters at all, right? Why not go 0, 0? Why not do it right on the line? And the answer is because I've been burned before. It's better to have a little bit of slop, a little bit of give, just to make sure it fits. And then, in the future, you can actually put tighter tolerances on certain areas of the board, talk to your manufacturer. But that is a message you need to have with your manufacturer, or conversation you need to have with your manufacturer, or else, if you just choose any random online manufacturer, you might just be disappointed. All right. Wow. That was 43 minutes, but I had actually hoped to be, I have an alarm going off in 2 minutes because I have an appointment coming up soon, and that is what I hope to do. Okay, so that's great. Look at that. Let's do a little render as a nice, as a present to ourselves. We'll 3D model, get the good feelings here. This will probably be the visualization for my next live stream. Yeah, like that. One thing I didn't do actually is re-export this as a 3D model to put into FreeCAD. I could, but I've kind of validated what I want to validate so far. Let's just turn on the ray tracing. I'll take a second here. Celebratory Diet Coke sip. Oh yeah, look at that. That's nice. Let's take a screenshot. All right. I'm posting that in the channel, in the internal Slack channel. Okay, so that's great. I appreciate the questions, Yagesh. Yeah, sorry. And hopefully, once we send this out, it looks good. Future things that I want to do on this board. So one, obviously put real components on here. I need to actually assign the pins in the schematic for like hooking things up, right? So now we have 2 click headers, but I want to make sure that the click headers match signal-wise. They match mechanically, they match footprint-wise, but now I want to make sure they match signal-wise so that when I go and start doing a, so then now if this is a template for future boards, I want to make sure it's right. And then I actually want to go make that board, right? So the first one, I'm going to put some big relays on here, some other terminal blocks. In theory, it should be very quick. Probably quick in this case is like a 45-minute live stream instead of like a 4-hour live stream. There's that alarm. End live stream. That was the alarm that was set on my phone. And then hopefully get it made. Other than that, I would also like to put a, so these footprints here are for are for reverse firing LEDs. They're optional, but then putting a optional I2C expander on here as well. Maybe even a little bit of fun, maybe doing something like a CH32 V003 and making my own 3D or my own I2C expander or something like that. Okay. Well, I appreciate you all spending your time with me here today and being patient while I'm off screen doing file management. I should really do this from like a clean computer, so don't worry about that sort of thing. But if you have any questions, you can always post them in LinkedIn. I should see them on there. I think YouTube might let me know. This is on the Goliath account. So it might be some of my coworkers in the marketing group that see it first. But you can also go to our forum, forum.goliath.io, or reach me on Mastodon or LinkedIn. Happy to chat with you all. Thanks for being here and hope to see you in a future session.